Good night, students. Welcome again to another tape session for IYMS 1001 or for Math 0103 students. Tonight, what we're looking at, we're continuing from what we started in this session. We are going to take the symbols that we met and we're going to place them with the questions and actually look at how to handle the questions and how to interpret the questions. So we're actually going to we're going to take our Venn diagram, we're going to create our Venn diagram, we're going to put the information into the Venn diagram, and we're going to answer questions based on the Venn diagram and on sets. And the information that we'll be using symbols, and we'll be meeting some new concepts too. So let's say we have a universal set, and I'm going to do a quick sketch of our universal two sets and our universal set. So I have my two sets there, and I have my universal set, and I'm going to put the numbers. I'm just going to type all the numbers very quickly that we're going to place in our universal set. So our universal set contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the elements of our universal set, and I'm going to place them into our Venn diagram, and our Venn diagram has the element. The two sets that we have, before we move on, we name two sets that we have, the sets A and set B. So let's start putting information in. We have our two sets, sets A and set B. And we're putting in our elements into the set. So let's say our set A has the elements 1, 3, 5, 6, and set A has the elements 1, 3, 5, 6. Set B has the elements 5, and set B has the elements 1, 3, 4, 6, 7, and 8. So the sets the elements 2, 9, and 10. But we found, because they're not in set A or B, they are actually in the universal set, but they're outside of sets A and B. Alright? So we place the information into our Venn diagram, and let our information, when we place the information in the Venn diagram, it looks like what we have across here. Alright? So now let's look at some questions that we could be asked about this. Note, the only thing left out here is our symbol for the universal set. So our universal set, this represents my universal set. Alright. So let's say we ask to give A intersect B. A intersect B. A intersect B will be what's common between A and B. So that will be the elements 1, 3, and 6. Okay. If asked A union B, A union B, A union B, we're looking at taking all the elements of A and taking all the elements of B and joining them together. So if we're doing that, we're looking at, let's highlight the regions that we're referring to. A union B will be this region, which represents my set A, this region, and this region, which represents my set B. So A union B would be the entire region that we have indicated in green on the screen there, because it represents we have our region A and we have our region B, both joined together. So for A union B, we will have, going to write it out. First thing, you put your curly brackets, and we go 1, 3, 4, 5, 6, 7, 8. Now, those will be A union B will be 1, 3, 4, 5, 6, 7, 8. Now, there's no rule saying that you have to keep it in increasing order or giving any order. All it says is that you have to have the elements that are indicated in the region that we are highlighting here in green. So you can have it in any order, but for me, I like to have my answers organized, and I just like to state my numbers in increasing order, starting from smallest to largest. Now, let's see how the questions could change. They can ask you A union B prime. A union B prime. First thing you need to identify what A union B is. We have our A union B indicated here already. A union B prime is, first identify A union B, and we're looking at the complement of that. So if A union B is what we have highlighted in green, right, then the complement of that is what we have in the universal set after we take out A union B. If we identify our A union B and we remove that, what do we have in the universal set? We have the elements 2, 9, and 10. So my answers for this is going to be 2, 9, and 10. Alright. So that represents my A union B prime or A union B complement. So anytime we deal with a question where we have the complement or the prime, identify what the set is first, and then do our complement of it. To look at what is, after we identify set, look at what's remaining in the universal set. Let's look at another question that we asked. A intersect B prime or complement. Then first we need to identify what is our A intersect B. A intersect B represents numbers 1, 3, and 6, right? So A intersect B complement will be 2, 4, 5, 7, 8, 9, 10. So the first thing we will need to do again will be identify A intersect B. A intersect B would be that region in green. So the complement of that is everything else in the universal set except for A intersect B. So if you notice, A intersect B will be 1, 3, and 6. So you take out the 1, 3, and 6 from the universal set, and whatever you have, all that you have remaining represent the A intersect B complement. Simple? I hope you do find it simple. Alright, now I'm going to add a new twist in. What if you had A intersect B prime? Now notice there's no bracket, so it means that you're looking at what is in A, what is common with A, so what is in A and outside of B, because our B complement means at the same time. So we're looking at what is inside of A and outside of B at the same time. So think about it. We're looking at, so let's put some colors on this. Let's say this represents my E, alright? And let's say B complement will be everything outside of B, which will be this region and this region. So that's everything outside of B, and this is E. And intersect means what's common between the two of them. So let me put different colors to clear it up so everyone can follow what we're looking at. So we have the red region and this orange region to represent A, right? We have the orange region and the yellow region to represent B. Alright, the orange region and the yellow region represent B. And we're going to put blue to represent everything that is outside of A and B. Alright? So now let's understand. We're looking at A. Which region represents A? A region represented by A would be our red and orange region. Okay? Now we're looking at which region represents B prime. B prime will be represented by our red and blue region. Okay? Now when we say intersect, we are looking at what is common, which region is common. The region that is common would be that red region that we have indicated there. So remember, A will be red and orange, B prime would be red and blue. Intersect is what is common. The only region that is common is our red region, and that would be the region that is common. So my answer to this question would be 5. So I'm going to put my Venn diagram there. Look at our Venn diagram. We put our equal sign to put in brackets, and the answer to this will be 5. And if we were to actually put the colors and just state the colors and everything, A intersect B, we're looking at A as the red region and the orange region. And we say intersect what is common, and B prime, A so intersect B prime. B prime is going to be my red region and my blue region, right? So when we say intersect, we are looking at what is common in both of them, and the only thing that's common in both of them will be the red region for both sets. Everybody follow that? So it means that the only thing that is common with my red region in both sets, so, and the red region is what we have as the 5. Okay? Now, if you follow that, I want you to try this question for me. Give me what is A prime intersect B. A prime intersect B. So let's see what it comes with. So we want A prime intersect B. Now you can either use the colors, you can either use, see if we can figure it out. A prime intersect B. First thing, A prime will be the region what? Blue and yellow. Correct? So we have a region blue and yellow. And yellow. Okay, and we're looking at what's common between that and B will be the region yellow and orange. So when we say intersect, what we're looking at what is common, and both are the only that's common, but that would be the yellow region. Yellow region. Alright? Now, moving away from the colors, let's see if we can describe it. A prime intersect B, we are looking at what is outside of A and inside of B at the same time. We look at outside of A and inside of B at the same time, and the only area that we are looking at is the yellow area here, and that yellow region is the set we're going. The only region that we have is set will be 4, 7, and 8. 4, 7, and 8. Outside of A and inside of B at the same time, 4, 7, and 8. Everybody follow that? Okay, let's make sure everyone understands. Okay. Let's do another twist. Let's see. We're going to still staying with the complement, and we're going to look at another question dealing with complement. And let's clear the screen a little bit, but we don't want to get a little too complicated and too cluttered. If I ask you for A prime intersect B prime, A prime intersect B prime, everything outside of A join together with everything outside of B, right? And we're looking at what is common between the both of them. Everything outside of A will be what? Blue and yellow, right? Everything outside of B will be blue and red. If we say intersect, we're looking at what is common. So everything outside of A, we're looking at blue and yellow, and B prime, everything outside of B, we're looking at blue and red. And when we talk about intersect, we're looking at what is common. So the only thing we have that is common is the region, is those two regions in blue. Now let's put it in a different form. A prime intersect B prime. We're looking at what is outside of A and outside of B at the same time. So we're looking at what is outside of A and outside of B at the same time. So we look at it outside of A and outside of B at the same time, and our answer is going to be 2, 9, and 10. outside of A and outside of B at the same time. Alright? Okay. Let's look at another question. I'm going to stick with the complement right now because it's something that gives a lot of students a lot of problems. What about if I ask A prime union B prime? Think about it. A prime union B prime. We're taking everything outside of A, join that together with everything outside of B. So if we look at that, I'm going to clear all the colors out just for a second. Okay, so let's look at it. Everything outside of A, we're going to give it a color. Let's make everything outside of A green. So everything outside of A is green. Alright? And we join that together with everything outside of B. And let's say we continue to make everything outside of B a green but different green. Everything outside of B. And we join it together. You realize that no matter what, that region in the center will never be colored. So everything outside of A joined together with everything outside of B gives us this, what we have here. Everything outside of A union everything outside of B gives us those three regions colored, and the only region that is not colored is the center region, which represents the elements that are inside of A and inside of B. So if they're inside of A and inside of B, then there's no way we could join it. We will ever get that region colored, because we look at everything outside of A joined together with everything outside of B, and our answer for this would be everything except the 3, 1, and 6. So let's go. So we're going to get 2, 4, 5, 6 wouldn't be there, 7, 8, 9, and 10. Okay, so it's 2, 3, 4, 5, not 6, 7, 8, 9, and 10. Those will be 1, 3, 2, 4, 5, 7, 8, 9, and 10. I think I said 3. 2, 4, 5, 7, 8, 9, 10. Those will be 3, 1, and 6 will not be there because they fall in the region where they're either in A or in B, because they're in both of them. Either how you look at it, that region in the center is represented by the elements that are in both sets, and we're looking to join everything outside of A and everything outside of B. At no point in time 3, 1, and 6 would ever be considered, because 3, 1, and 6 is not outside of A, and 3, 1, and 6 is not outside of B. So at no point in time we are going to get that element, those elements, to join this set. Alright? Okay. So let's move on from complement. Let's look at questions with number of elements. Just a quick question with number of elements. I'm clearing and taking all the colors out. If you're given the set, given the question, sorry, N A union B. N A union B, we're looking at the number of elements that are going to be in A union B. So you need to identify A union B. First thing, let's identify A union B. We're going to get A union B orange. So So this is A union B is going to be 1, 2, and 3. That's what A union B. And N A union B is that we're going to count the elements that are in the number of elements in this set is going to be 1, 2, 3, 4, 5, 6, 7. So our answer is going to be 7. So we're going to just we don't put brackets in, we just put in 7 because the question is number of elements in the set. If you put brackets on it, then your answer is wrong, because if you put brackets on it, you're saying a set with the element 7 in it. Alright? Okay. So, next question. N A intersect B prime. The number of elements in A and outside of B at the same time. Think about it. That's what it's asking for. So we're looking at A. If you're looking at A, we're looking at these regions in red. That's A. And we're looking at B prime. And B prime is going to be these two regions in red. So when we talk about intersect, we're looking at what is common, and our answer would be this region that we indicated there. Because if we looked at A and we looked at B prime, that region was always shaded or colored red. So my answer for this is going to be not 5 but 1. Making sure you understand, it's not going to be 5, it's not the element after the number of elements, and the answer is going to be 1. Outside of B and inside of A at the same time. Only one element satisfies that. Alright? Okay, and our last question that we're going to look at, a question involving subsets. So, let's say you're given a set C, and set C has the elements 2, 3, and 5. Okay, and you're asked the number of subsets that could be formed from set C. Anytime you hear a number of subsets, you're looking at the first thing you must look at is the number of elements. And if you ask the number of subsets to be formed in set C, from set C, it's 2 to the power n, where n represents the number of elements in the set. So if you look at the number of elements in the set, we have 3 elements, 2, 3, and 5. So if we have a number of subsets that could be formed from set C, we are looking at 2 to the power 3, which is going to be 2 by 2 by 2, which is going to give us 2 2s are 4, 4 2s are 8. So we have 8 subsets could be formed from that set. Alright, and the subsets are going to be based on the combinations that you have and how many combinations that could be made from this set. So let's see. We could have a set with single elements, that's 2. We can have 3 and 5. We can look at sets with 2 elements in it, 2 and 3, 2 and 5, and 3 and 5. And if we total this up, we only have 6. Where the 8 subsets coming from? The next subset is the empty set, and the next subset is the set itself. So anytime we're thinking about subsets, as I said, we deal with one, we look at the number of elements, and we can work out a figure for that, because it's will be 2 to the number of elements that you have. So if you had 5 elements, it would be 2 to the power 5. But when we look at listing the subsets, we start doing all the combinations. We do sets with 1 element, sets with 2 elements, sets with 3 elements, if it has, depending on how many elements you have in the set. But always remember that you must include the empty set. You must include the empty set and the set itself, the original set. So these represent 2 of the subsets that you have. So when we look at it and we total up, we have 1, 2, 3, 4, 5, 6, 7, 8. So that's all 8 subsets that we're looking at. And if we were asked to make a set of the subsets that could be formed, then all we have to do, we list those 12 subsets and we put brackets on it, because if we are writing a set, we must have the brackets, the curly brackets, and we put commas in between the individual subsets. So this represents a set with all the subsets that could be formed. Okay, alright, so just a quick question. If the set had 5 elements, if set C had 5 elements, how many subsets could be formed? Think about it. If set C had 5 elements, how many subsets could be formed? And if it has 5 elements, the number of subsets to be formed will be 2 to the power 5. So if set C has 5 elements and we're looking at how many subsets that will be formed, we're looking at 2 to the power 5, which will give us 2 by 2 by 2 by 2 2. So we're looking at 2 by 2 4 by 2 8 by 2 16 by 2, which will give us 32. Alright, so 2 by 2 by 2, so it will be 2 to the 5th power, which will give us 32. Alright, so I hope that you were able to follow what we did. We used our information that we got from the last session. The last session we looked at the symbols for the sets, and now we start to use them and incorporate them into questions that we have on sets, where we looked at using the symbols with union, intersect. We also use the symbol for prime and or complement, or even we use our understanding of subsets to answer questions and common questions that we will normally ask in terms of sets. So I hope you found the session to be informative, and I hope you were able to pick up and add to your understanding of sets as you read through the material for the course. Note, questions like these are common in the final exam, and you will see them in most of the past papers. So familiarize yourself with how the questions are handled, because you never know when you'll see them again.